Hello and welcome to this repair overview tutorial, and today we're going to be looking at a Cambridge Azur 340A audio amplifier. And this amplifier dates back to 2004. That's when it was sort of available for sale. But in 2006 Cambridge also released an SE version, but for this repair tutorial we'll only be talking about the 340A. So just before we sort of kick into this, really just probably a shout out to Cambridge Audio. I've sort of been working with Cambridge Audio, for many years, and like many of the audio brands, they've gone through different phases in terms of business and been acquired by different companies. But really a positive shout out to Cambridge Audio with regard to support. So in the case of the 340A, what's available if you do a web search is the 340 SE service manual, and you can of course use that then for the 340A. But I did actually have cause to contact Cambridge Audio literally in the last few weeks to look to see on the availability of U1 for another 340A series amplifier, which is the PIC, which is the microcontroller, which is mounted on the front board where you have the input selection, just to inquire if that audio IC was still available. And literally within less than sort of an hour, you got an email back coming from Cambridge Audio, and then the first thing they just sent you was just a little disclaimer just for email. And then the next thing they tell you is they're going to send you the service manual. Well, I was like, yeah, okay. And there's no charge for the service manual, so they're more than happy to send across the 340A, and you just specify the part number and the component that you're looking for, and then they will then go back and then check on availability and stock and all of that good stuff. So unfortunately, U1, the PIC micro for this amplifier is not available, but I totally get that, if you're sort of looking back to 2004. But really great customer service from really an audio brand which has a huge number of followers. And I've said in previous repair tutorials, how close are you to the customer? And that kind of customer support and service really, to me, speaks volumes. It's not so much when you're buying equipment, it's sometimes when you want support or maybe something goes wrong. If a company is very responsive, very open, supportive to get that sort of piece of equipment back up and running, that to me builds a lot of sort of loyalty around the brand. So yeah, that's a shout out to Cambridge Audio on that. Alright, so if we look at general specifications, so for the 340A, you've got an audio power output of 40 watts into 8 ohms, and then it will actually deliver 50 watts into 4 ohms, so that's good in itself. And it is microprocessor based, so you have a remote control, and that can put the amplifier into standby mode, but you can also operate the volume control, and then any of the input selections as well. So on the main board you have a common IC which is U4, and that's a Toshiba device, and it's the TC9163. So that is an input selection integrated circuit, and it is controlled directly from U1, which is the PIC16F22 microcontroller. But be aware, if you went off and you tried to source one of those PIC chips, you need the firmware that has to be loaded into there. So if you did have such a failure where you needed a replacement micro, you're probably going to have to go out and take maybe a donor amplifier which was beyond economical repair, and then use that one. And then in terms of for circuit processing, you have multiple NE5532, which are dual operational amplifiers. And then for the output stage, it's not a traditional transistor or MOSFET type of output arrangement. What you have are dual, so you have one for each channel, and that's a dedicated audio output IC, which is the LM3886, and the amplifier can provide dual outputs. So again, these are selected via the mechanical switch on the front, so that push button switch operates, and that will select speaker set B and A. And then you also have a direct mode, so again you can bypass, if you wish, the tone circuits. Then you have the balance, treble and bass controls, and straightforward volume controls. And then when you look from the front face, you'll also see the small little round window, which is where the infrared commands get sent directly to the amp from the remote control. So let's talk to you about what the issue was with this amplifier. and it sort of comes back really to the way in which the amplifier has been manufactured to some degree. So when you look at the video, the issue that the amplifier came in with was that there was really a loud sort of buzzing or humming sound on the left channel, and no matter if you changed any of the inputs, then the fault was still present, and it didn't matter if you selected the direct mode to bypass the tone circuits, you still had this noise. Now what it did is it ruled out a common cause. So I wasn't really looking at a power supply issue here, because the power supply of course is common and it will also feed the right channel as well. Now that kind of fault that I've described there could be caused by failure of the Toshiba integrated circuit for the input selection. And just as insight, you can get a failure of these where maybe the user has connected directly to the CD input, and then what they do with the amplifier still power, maybe they disconnect the left input and then move it then maybe to the aux and then plug it in, and then you get this imbalance which can then destroy the Toshiba chip. And it's a surface mount device located underneath of the board, and that can cause that issue. So when you do the input selection, you can get crosstalk coming across all of the inputs, or you'll get this noise, or maybe complete loss, or even to the point where literally the IC will fail short circuit inside and you'll see a burn mark or hole on the input selection IC, but not in this case. And you can also get noise which could be related to one of the, or maybe more, failures of the dual operational amplifiers on the tone circuit input processing circuit, or it may also be due to the LM3886 for the respective channel. Maybe the customer's inadvertently incorrectly wired the rear speakers, or a wire got shorted or something happened, but none of that. The issue here was that when the top cover was removed, and literally you put just a small amount of pressure on the board, the noise would go away straight away. So it's one of those intermittent type faults, but very, very easy then to recreate. So a bit of pressure on the top of the board, fault went away. As soon as you remove any pressure, it returns. And you can home in towards the front, so literally around the volume and balance control. Very, very light pressure there, clear the fault, then it would then come back. So that told me maybe I had an issue with one of the control potentiometers, but based on experience, I'm also aware of the way in which they manufactured this amplifier. So what the video is showing is during manufacture, when they put the front fascia onto the amplifier, there's a very, very close tolerance, which if they didn't put any form of insulator underneath, you would literally short out probably some of the pins of the control potentiometers, for example the balance or treble or bass control, and that of course is a major issue. So what they've done is they use like a plastic strip, has holes either side, and then they use a cable tie, and literally they also use like a white glue to bond it on. But that's not really the cause of the issue. That's just to prevent, when the screws are inserted underneath to hold the front fascia to the bottom base plate, shorting the leads of the components out. What you'll see, and I've shown it in the video, when they manufactured the board, they literally take some side cutters and they cut the pins of the control potentiometers so low, they even take the top half of the solder off. And that's the issue here. So what you find is there's dry joints on here, and that's what the issue was. It was literally a dry joint which is on the balance control, and when I was just pushing it down, then that was clearing it and making a contact. Now again, as insight, the problem with that type of repair is it's not feasible to remove the potentiometer, so the balance control, and then solder a lead onto there and then push it back through, because the height is critical how it aligns then to the front fascia. So what I'll do is I'll turn it over, and I'm showing you in the video, what I'll do is I'll use component leads. So when I'm doing maybe recapping or replacing components in amplifiers, I'll just collect up all of the offcut leads and I just have them in a bag, and they're really useful for repairing tracks or broken tracks, but perfect for this repair, because what I can then do is I can then insert one of those component leads that then makes direct contact then with the existing potentiometer, one of the pins which have been cut too low, and then when I then solder, what will happen is the solder then will be drawn down, and then it will make a very, very secure connection to the pin of the potentiometer. and then I can have that nice concave shape where I can then cut off that component lead, and I have a very, very solid connection. And that's what I'm showing in the video. So I do this to multiple components. So I didn't just stop at the balance control, because I could also see that the treble control had also been cut too low. So I literally go along and I desolder all of those, and then I'm inserting these component leads, then reflowing them and then cutting them off. Now the plastic sort of insulator had become brittle over time. So what I've done there is I've just got some insulating heat shrink sleeving, and then I've then cut it to size, and then what I'm able to do is to recreate another insulator as well then, and you can see that I'm showing that in the video. And then once that was done, rather than me doing like a full reassemble, what I'll do is I'll put back the amplifier into the main chassis, and then what I'm also doing then is I put power on, and then I'll put the headphone socket in, and then I start to apply pressure. When you look at the main board, you have multiple fixing screws, so they're either side of the heat sinks, and then there's two at the front and the rear. But what I'm not doing is putting all the screws in for the side panels, and then the screws underneath, and then the screws at the front. All right. You may find during testing, sometimes even with some of those screws removed, the fault might appear, but not always. So here, once I'd remade all those solder connections with the component leads, I was confident that that was then a good repair. What I also show you as well is the volume control potentiometer removed from the board. And the reason why I show you that is for the Cambridge audio amplifiers, and this dates back to the A5 series, A1, A2, the volume control potentiometer has longer leads or longer legs, and I'm just showing that that is out of the board. And then also in the repair video, what I've done is I've took an extract from the 340A service manual, and then what I'm showing you there is the balance control potentiometer. So this is a dual gang potentiometer, and then normally when you select the direct mode, of course it would then switch the tone circuit in circuit or out of circuit. And then as part of the repair, I'm also cleaning the user control potentiometers as well, just to make sure that there's any noise or anything like that. So all good. And then also the headphone socket, but because I've got the board up, I also scan across there to make sure that there's no dry solder joints. With the 340A or the Azur series, you don't tend to find them as some of the other brands. Some of the other brands, like some of the Sony amplifiers, you'll always find dry joints. In this case, there was a few dry joints, but nothing sort of really major or anything like that. Because you have these fixed audio output ICs, there was no requirement either, to set up any bias adjustment for the output stages. They were already done. So once the issue with the noise due to the intermittent contact on the balance control potentiometer was rectified, it was literally a case of just reassembling the amplifier and then just doing a full functional test. The speaker protection relay is located close to the front, not too far away from the headphone socket. And this brown glue that I've spoke about before, there was a little bit of brown glue, but it was over towards the low voltage power supply, just on one of the smoothing capacitors, just on its outer plastic covering, but it wasn't making contact with any other components, and no issue with sort of cross contamination on any of the circuit boards. So there wasn't a need to remove that or do anything with it. What I would say for anyone who's undertaking the repair, there are a hell of a lot of screws, just a phenomenal amount. So you're going to be there, taking a lot of screws out to get the amplifier into a position where you can lift up the main board. Also as well, what they do from the toroidal transformer is they bunch up all the different power wires, and then they'll use a cable tie and cut it off. You'll need to remove that cable tie just to release, so you've got some slack. And then what I also do as well is just desolder the earth, because that wire is quite short and you won't be able to lift up the amplifier to get access to it. So once you are able to just remove that, you can then lift up the amplifier, and then you then can carry out the necessary work then. Alright, so that sort of brings us to the end of this overview repair tutorial. So as always, I thank you for listening, and thanks very much for stopping by. Until the next time, thank you.